about this equation and this question in general. Over the past couple days, you guys have been working on this. So first you look at this equation, it looks pretty daunting. You're like, wow, there's a lot of elements. Wow, they're all over the place. All these compounds are really big. So where do I even start to balance it? Well, this one is not as bad as it looks because most of these are polyatomic ions. We have ammonium here and here. We got phosphate here and here. We have nitrate here. Nitrate here and here, and then we have lead. So it doesn't always work like this when you're dealing with polyatomic ions, but since all of our polyatomic ions appear on both sides of the equations, I'm going to treat them like they're individual elements. They're always going to stick together throughout, especially since we don't have any other random stuff that we didn't underline on our product side. So it looks to me like they're all going to stick together. So we're going to start with NH4, or ammonium. And we have 3 of them on this side. And then PO4, we have 1 of. And then lead, we have 1. And nitrate, we have 4. So that's where we're going to start. Let's go list them in the same order on the other side. NH4, we have 1. PO4, we have 4. And then lead, we have 3. And nitrate, we have 1. Okay, so let's just start with our ammonium, and we'll balance it first and see where we get from there. So we've got 3 on this side over here, and we've got 1 over here, 1 ammonium, if you put parentheses around that. So let's multiply this by 3. I would put a 3 there. That would also multiply this by 3. Okay, so I'm looking at this, and real quick, I know that multiplying that by 3 is not going to make those 2 equal. So I'm going to go ahead, I'm always checking, seeing what that's doing to the rest of the elements in the compound. And I'm like, okay, let's go ahead and move on. So I'm going to pull my eraser out and decide 3 might not be the number there. So let's look at our next one. We got PO4. On the left-hand side, we've got 1 of them. On the right-hand side, we've got 4 of them. Let's try that. So let's put 4 on the left-hand side. Oops. So that's going to multiply this by 4, but it's also going to multiply this by 4. Now it doesn't matter what I end up with of ammoniums, because this side I've got 1, so I can change it. So that's fine. So now we have 4 here, and these 2 are the same. So currently, those 2 are balanced. Okay, now let's move over and deal with lead. Lead, I've got 1 over here. I've got 3 on the right-hand side. So let's multiply by 3. So I multiply by 3. That's also going to change this by 3. So now I've got 3 here and 3 there. So that's good. Now when I made both those changes, I see that both of these are 12, which is handy because the ones I need to change are both 1s. So it's easy to change both of those to 12, especially since they're in the same compound. I just need to put a 12 here. So multiply both these by 12. and we are now balanced. Now that we're balanced, we're ready to start working on the actual problem part. So we have 4 NH4,3PO4s in a ratio to 1 Pb3PO4, or lead phosphate, and ammonium phosphate. So the question asks is, we react 109 grams of this, so that much reacts, that we know. How many grams of this are we going to end up with? So we need to go from grams to moles to moles to grams. Those will be our steps. This will be grams of PbPO4. Let's see here, try it right. This will be grams of ammonium phosphate. And then moles of the same and moles that we change. So to go from grams to moles, our steps, we need to divide by molar mass. So step 1, divide by molar mass. Step 2, use our molar ratio. So we want to get rid of an H4PO4, so 4 is going to be on the bottom. This is step 2. We're going to multiply by something over 4. In this case, it's a 1. We're looking for 1 over 4. So multiply by 1 mole of Pb3PO4 for every 4 moles of NH4PO4. And then our final step is to multiply. So step 3 is multiply by molar mass of this, and this of course is the molar mass of that. So we're going to do that on the next page. So NH4,3PO4. We need to look up the molar masses of each of these elements. So go to my periodic table, wherever it may be. Nope, not mine. Activity, here it is. So we need to look up the molar mass of nitrogen, hydrogen, phosphorus, and oxygen. So nitrogen, 14.0067. Hydrogen is 1.00784. Phosphorus and oxygen. Phosphorus is 30.9737. And oxygen is 15.9994. Okay, now we got to figure out how many of each of those we have. So nitrogen is inside these parentheses, so we've got 3 of them. Hydrogen is inside the parentheses, and we got 4 inside the parentheses, 3 outside, so we got to multiply those, so that's 12 of them. We have 1 phosphorus, and we have 4 oxygen. We also need to multiply those all together and add them up. So let's go to our calculator. And 14.007 times 3 plus, we'll put everything in parentheses just to keep it together, 1.00784 times 12 plus 30.9737 plus 15.9994 times 4. Equals 149.08638. Zero 8638 grams per mole. So if we go back, our first step is to take what we have, the grams of that, and divide by the molar mass. So we got 109.6 divided by 149.0838. So 109.6, I like to write it like this, times 1 mole over our molar mass. Grams, we see our grams cancel out. And then our next step was to multiply by 1 and divide by 4. And then we need to multiply by the molar mass of Pb3PO4. So the only new element we need to look up is lead. Let's go to our periodic table, look up lead, and lead is right here. Lead has a molar mass of 207.2 grams per mole. And then we've already looked up phosphorus and oxygen. So we can just use the numbers we've already looked up. Phosphorus is 30.9737. Oxygen is 15.9994. Then we have to figure out what we need to multiply each of those by. Lead is times 3. Obviously there's 3 of them. Phosphorus 1 and oxygen 4. So let's go to our calculator and do that. 207.2 times 3, that's lead, plus, oops, plus 30.9737 plus 15.9994 times 4 for oxygen. And that gives us 716.5713 grams per mole. So we are going to take that, if we looked at that last step, we need to multiply by the molar mass. So we're going to multiply by 716.5713 grams per mole. This is mole, and this is mole. So when we punch this whole series of numbers into the calculator, what we're going to do is 109.6 divided by the molar mass of our ammonium phosphate, which is 149.08638. Then we are going to multiply by 1, divide by 4, so we don't have to do it, enter the multiplication, but we do need to hit divided by 4. And then we are going to multiply by 716.5713, which was our previous answer. So we'll just select that there. And we will see that the mass of the lead for phosphate that is produced is 131.695823723132886. But we're going to round it to 4 significant figures because that's the number that we were given at the beginning, and it has 4 significant figures. So when we look at our calculator, we're going to get 131 point. That 6 is the number that we are going to round, and since it's a 9, we are going to round it up to 7. So the answer for this problem would be 131.7 grams of lead 4 phosphate.